In this video, we're finally going to start to put some functions together. So a lot of times we'll use an F and G and H and some other different letters for functions. Anyway, some different notations you might want to know about sum, difference, products, and quotients are these. They might give it to you in this form where the F and the G are together and they're saying like they're adding, for example, like F plus G of X. That is the same thing as F of X plus G of X. So whether you see it like the left side or the right side for any of these is going to mean the exact same thing. All right, so now that you know that, let's try a few examples. All right, these first two problems, it gives us what F is and what G is, and it's asking us to put together with addition and subtraction F and G. All right, so just a reminder that F plus G of X could be rewritten, then that's the same thing as F of X plus G of X, like we saw kind of in that first section, all right? In other words, if I just take what F of X is and what G of X is and plug those in, I can almost kind of substitute those in and then put them together with math that we should really know how to do already. All right, so for example, F of X says 2x minus 1, I'm just copying this from up here, plus the G of X is 2x squared plus 3, all right? And this is just a polynomial. We know how to put these together. Typically, you use the one with the biggest exponent, in this case the 2x squared. The next term would just be the plus 2x, and then negative 1 plus 3 would be a positive 2. Okay, so you get 2x squared plus 2x plus 2. All right, same idea for the second one. It's just F minus G of X, but with negatives you have to be a little bit careful because we're still going to take all of F, which is 2x minus 1, but then I'm subtracting all of G. And when I subtract this, you might want to put it in parentheses because since you're subtracting all of G, it's 2x squared plus 3. This negative does have to get distributed in. If you don't do that, you will end up making it look a lot like the first one, and we want to be subtracted, not added, okay? So if I do this here, this is going to be, let's see, 2x minus 1, negative 2x squared minus 3. Okay, now I can put those things together, negative 2x squared plus 2x, and then negative 1 minus 3 is going to be a negative 4. So very similar, but they are different for one when we add and one when we subtract. Let's try a couple more. All right, as you probably guessed, these next couple we have multiplication and division. So same ideas here. This first one we're going to take F of X, which again is 2x minus 1. Since we're going to be multiplying times G, I might throw it all in parentheses. And same thing for the G, which is 2x squared plus 3. All right, and since this is a binomial, two terms times another binomial, we'll have to FOIL this. All right, so first we have 4x to the third power. Outer is going to be plus 6x. Inner is going to be minus 2x squared. And then last is going to be a negative 3. All right, go ahead and put this in descending order as far as your exponents go. The largest one is a 3. So 4x to the third power minus 2x squared plus 6x. Then lastly, our constant is just minus 3. Okay, so I think that's what you get when you multiply F times G of X. F divided by G of X for number 4. A lot of times with fractions like this, you have to usually leave it as kind of just one on top of the other. I'll show you what I mean. All right, so number for F of X, this is just going to be 2x minus 1, and then over the G of X, 2x squared plus 3. Whenever you have multiple terms in a fraction, it's really hard to simplify unless we get into some rational equations or rational expressions, which we'll do later. But here, like I can't factor anything out, so nothing would be able to simplify. So I think a lot of times you just have to leave it like that as a big fraction. All right, the last few problems that we're going to do actually are going to combine kind of what we've already done with today's lesson. And that's going to be where we do like F plus G times a number instead of an X, okay? In this case, it's going to be a 3. So I have a new F and a new G function. And what we could do is we could put this together the same way, right? Take our F, which is 4x plus 1, plus the G, which is x squared minus 2x. And you could put this together right now and get this. This would be what? X squared plus 2x plus 1. All right, and then you can plug the 3 in for all your x's. So I like to leave open spots using parentheses wherever I see an x, and in those x I'm going to put my input of 3. And so let's do that. 3 squared is 9 plus 6 plus 1, which is 16. Okay, that's one way. Another way that is totally viable, and that is that you could just plug in this 3 right away. For example, let's try it. Let's put the 3 into my F function. So instead of F of X, I'm going to do F of 3. 4 times 3 is 12. 12 plus 1 is 13. Right, and then over here, if I plug it in for G, this would be 3 squared is 9. 9 minus 2 times the 3 is 6. 9 minus 6 is 3. So 13, remember it's plus because it's the plus g. The g we got was 3. And that is also, of course, a 16. Now you might have to show a little bit more work than I did, but you do get the same exact answer. All right, let's try number 6. This time f minus g of 4. Here you do have to be a little bit careful again with that negative. I'd probably use parentheses if I were you. My f function is 4x plus 1. And then again, minus, I'm subtracting all of g, which is x squared minus 2x. In fact, maybe here is where I'll put in my 4. Let's try it. 4 times 4 is 16, plus 1 is 17, minus, and then over here, 4 squared, again, is 16, minus 2 times 4 is 8. Okay, so use order of operations, do the parentheses first. 16 minus 8 is 8, 17 minus 8 gets me 9. All right, and that'd work if you would have plugged it in right away as well. All right, let's do a couple more. All right, last couple problems. We have one that's multiplication and one that is division. We're gonna do this the exact same way. This first one, let's do f, which is 4x plus 1, all right, times, and then over here in g, we're gonna go x squared minus 2x, okay? And again, we could FOIL this together, but I think an easier way would be just to insert my 2 right away and see what I get out. All right, so let's try it. Let's go 4 times 2 is 8. 8 plus 1 is 9. Times, over on this side, 2 squared is 4, minus 2 times 2 is 4. So this is like 4 minus 4, which is 0. 9 times 0, of course, is 0. All right. So you could have gone ahead and FOILed that out and got the same exact answer, but it saves you a little bit of time. Let's try f over g of 1. F of x again is 4x plus 1. G of x is x squared minus 2x. Again, if I plug in the 1 here, 4 times 1 is 4, plus 1 is 5 on top. And on the bottom, 1 squared is 1, minus 2 times 1 is just minus 2. In other words, we get 5 over negative 1, which of course is a negative 5. All right. Hopefully this helped you out with doing these operations on functions.